This is very exciting. Hi, this is Dale Peterson, and welcome to the Unsolicited Response Show. In this episode, we're going to be talking about CycloneDX SBOMs and more related to the software supply chain. Before we get to that, I just want to make one last plug. This episode's coming out on August 23rd. The S424 call for presentations ends in 8 days on August 31st. We still have good spots open. We still have spots on all three stages. We're looking for your new and important work. It's a great way to get your idea out there and make a difference. And as our tagline for S4 is, help create the future. So go to s4xevents.com/CFP. It's a very easy submission process. And if that's even too hard for you, just send me a couple of paragraphs to s4@digitalbond.com in an email, and we'll look at it, get back to you with yes, no, or some questions. And with that, Liz, let's bring on our guest. Our guest for this episode is Steve Springett. He is the Director of Product Security at ServiceNow, but probably a little more pertinent for this conversation we're going to have, he is the chair of the OWASP CycloneDX Core Working Group. So, Steve, welcome to the show.
Thanks for having me, Dale. Appreciate it. Glad to be here.
Well, I want to kind of set the stages for the listeners and viewers of what we're going to do. So I've told Steve that the audience knows what a software bill of materials is in broad terms, what an SBOM is, why you might want an SBOM as an asset owner or vendor. So we're not going to, get that level of basics, but we are going to cover at the beginning some basics on CycloneDX, dependency track, and other things. And then after that, we'll really dig into the gory details. So if you're an expert on this, check the show notes. It'll tell you where to jump to when we get into the more gory details. But Steve, maybe as a starting point, I go to the CycloneDX site, and it almost starts, I think, in the first sentence. CycloneDX was designed in 2017 for use with OWASP dependency track. I'm not sure my audience really knows what dependency track is. So could you maybe give a minute on what it is and what problem it's trying to solve?
Sure, absolutely. So dependency track was one of my projects that I started in 2013. And I had a quite simple use case at the time. We were selling, my employer was selling server appliances that organizations would deploy into their data centers. And the requirement was that I track everything that we were actually shipping with that device. And by everything, I meant the entire software stack. So firmware, operating system, OS packages, application libraries, all the different hardware and revisions of the hardware, basically everything that we were distributing to market. And essentially, it was a complete bill of material. And the requirement was that I have some way to track that, because different versions of the appliances would be available to us from our manufacturer when we sold these to market. So I had to track all the different revisions, and then obviously the software that was installed on those, so we could do things like vulnerability analysis and know what kind of risk that we had and that we were obviously selling out to our customers. So it was basically SBOM plus HBOM like 10 years ago. So that's essentially the problem that dependency track was designed to solve, and that's kind of a lot of the ideas that came about from that type of holistic view of bill of materials is what ultimately led to the creation of CycloneDX back in 2017, which is a bill of materials standard, which obviously does software. So it does software bill of materials, but it does a lot of other things as well.
And then the idea is, as I saw it, you have this nice diagram, and maybe I can put that in the show notes, where you've got dependency track, and then CycloneDX is feeding the various BOMs into dependency track. So is I guess, why didn't dependency track just do the do what CycloneDX is? Why did you have two separate components?
Yeah, that's a great question. We if this was truly going to be successful as an independent project, Cyclone DX needed to exist and be successful outside of OWASP. So we actually started Cyclone DX. So first of all, Dependency Track is a flagship OWASP project. Flagship meaning that there's three different levels of projects in OWASP. You've got incubator, you move up to labs, you move up to production, and then for production projects that have strategic relevance to the OWASP Foundation itself, then they become flagship. So that's where Dependency Track sits today. But if Cyclone DX was going to be successful, it needed to be successful outside of OWASP. It could not be viewed as a specification only for another OWASP project. And I think we were really successful in that because today, Dependency Track is just one of over 200 plus tools that we are tracking the existence of that actually support the standard today. So Dependency Track is literally just one of 200 known tools. There's probably a lot more than that. The 200 is just the ones that we know about today, though.
Yeah, I'm probably going to get in trouble here, but for example, in the OT space, we've got finite state, Adolis, NetRise, Fortress. There's probably more that are going to be mad I didn't mention their name, but they all, as I understand it, import or will take a CycloneDX BOM into them.
Yes.
At various levels of completeness of use, because we'll get into it. It's a very complete specification that can be implemented at a very simple level or at a very complex level. So that does seem to make sense. You mentioned this idea of not wanting it to be just an OWASP project, and that kind of gets me to the business model question. I've never quite understood. You've got CycloneDX, you're the chair of the working group. I'm sure people donate a lot of their time, but you've got websites, you've got various things that you have to do that cost money. How does CycloneDX, the effort, support itself?
It's a great question. So once CycloneDX became, I guess, a successful project outside of OWASP, we eventually moved it into the OWASP Foundation. We do have infrastructure like websites and stuff like that that we do need to support. Fortunately, the OWASP Foundation has funds for flagship projects to allow us to do this. So it's not like we're paying for things out of our own pocket. That's not what we do. OWASP is funded, and if you would like to donate to OWASP, it is a nonprofit foundation. So please do.
Okay.
But that drives a lot of what it is. CycloneDX really is not a business model. It's open source, meaning that it's really a development model. It's because it's an OWASP standard. It's very community driven, and it allows whether you donate to OWASP or not. OWASP takes a very idealistic view of vendor neutrality, meaning that if you are a single individual or if you're the largest corporation in the world that gives us a boat ton of money, it doesn't really matter. Everyone has an equal seat at the table, which then allows us to capture some of the best ideas that wouldn't have otherwise been possible. So that's really a development model for us.
And I guess I'd be skeptical of that if OWASP didn't have a history of making this model work. Because we've seen, for example, with Metasploit, started off this way and eventually went commercial. But OWASP is credible that this is likely to stay this way for a while. Maybe
absolutely. We've got 2 decades of, it's interesting because OWASP has got, it's certainly not a perfect foundation. Every organization has challenges. But over the last 21 years that OWASP has been around, I mean, they've built up an incredible reputation to the point where other standards in some cases just say, do whatever OWASP does. They know what's best. Like if you look at PCI DSS set of standards, at one point they were saying, OWASP top 10, 2017 or later. Doesn't matter that they haven't even reviewed the or later part. They just said, do whatever whatever guidance that OWASP says, and you don't get to that level of reputation overnight, right?
Yeah.
That's something that takes years and years and years to kind of build up that level of trust.
And I think I know the answer to this, but what are the competitors to CycloneDX? The other formats or other ways people might do this if they say, well, we don't want to do the CycloneDX way of documenting our BOMs.
Sure. The other machine readable format is SPDX. They have, well, it's a very, very different specification, not necessarily designed to be a bill of materials format, but they definitely came from the license and intellectual property space. So they're up until recently, they were kind of the leader in that space. But CycloneDX is very different. We actually were first and foremost a bill of materials standard. And we've come from the security angle, security and that sort of thing. And we've kind of moved into the license area as well. In fact, we support all the SPDX license IDs, all SPDX expressions, which are phenomenal, right? When you talk about SPDX is actually three different things, which a lot of people really don't understand. SPDX is one, a standardized list of license IDs, open source license IDs. There's over 2,000 plus open source licenses. SPDX is cataloged around 500 or so of those licenses. So each one of those has a dedicated ID. Number two, SPDX is actually an expression language. So if you want to express this license or this other license, well, you can represent that in an SPDX expression. CycloneDX supports both of these things. That's phenomenal work that SPDX team has done over the years. Where we differ greatly is in file formats. So their file format is very much tailored toward intellectual property and license use cases. Ours is very much tailored to bill of material and security use cases. So I would recommend that organizations actually take a look at both of the specs, actually read both of the specs, and start playing with different tools that might be available that support each of the specs.
And we do. Now, does dependency track support SPDX?
It did at one point. We ran into challenges with SPDX, and it kind of goes back to not originally designed to be a BOM format. In its current state, SPDX cannot represent what a component is, only what a component could be. And for a system like dependency track, which is essentially like an asset management application, the assertion of component identity is kind of a requirement. So we ran into some technical challenges with SPDX, which I believe they are rectifying in SPDX 3.0. So once 3.0 hits and tools are available to support that, what we plan to do is have a automatic conversion in dependency tracks. So when we ultimately get a SPDX 3 or higher bill of materials, we'll automatically convert that to native Cyclone, and then we'll be able to ingest it. So that's kind of our approach to doing it. But yeah, we're basically waiting for SPDX 3, which I believe solves some of these legacy SPDX 2 issues.
And I would say the companies in the OT space that are creating products that bring in these SBOMs are either doing both or have both on the roadmap at this point. And that who knows how long it'll be before there's a winner, or if we'll always have these two formats. But that's helpful to know. And then maybe one last broad question. Where, and this is a tough one, where are we now with SBOM? How, and especially if you can give it some OT market flavoring, how many companies are creating SBOMs in CycloneDX format? Are they sharing them with their customers, or are they just basically keeping them internal? We hear it's very, very new and very little is being shared in the OT world right now, but you have a much broader view, I think.
Yeah, I have the I certainly have the opportunity, the privilege of talking to quite literally hundreds of different organizations, whether it's cloud native shops to large OEMs to IoT device makers, that sort of thing. And where we are is, you know, industry and technology specific, I think. Um, in terms of adoption, we know that over 10,000 organizations use Dependency Track today. We know that well over 100,000 organizations use CycloneDX today. We also know that upwards of 400 million components in CycloneDX, over 400 million components are analyzed for known vulnerabilities every single month using only Dependency Track. And that's just one tool. So realistically, because we have 200 tools, you're talking of about realistically over a billion components per month, all originating from CycloneDX format. Um, Now, that is like the adoption, and the overwhelming majority of adoption that I've personally seen and talked to organizations for is really about that internal use case, that internal DevOps
Hmm.
SCA type of use case. That's where most of the folks are using this. However, I talk to large defense contractors. I talk to large OEMs, some of the largest companies in the world, and they are doing some really interesting things with them, right? They have their SBOMs, they have their HBOMs, they have them separated because many companies want the hardware and the software to be separate, which is great. And we know that many organizations are doing this today. What we don't have a lot of visibility in is how many are actually sharing this, right? Sharing is both a contractual, regulatory, and technological challenge, right? Technologically, there's no standards that exist to share today. So sharing means putting it on like an S3 bucket or emailing it or some of these other type manual
Yeah.
things that are just not scalable if you've got tens of thousands of vendors in your organization, right? I can't send 10,000 emails and manually process 10,000 SBOMs. We do have some proprietary solutions, which are great. They're doing a fantastic job. We've got things like DBOM, which is a Linux Foundation project. It's kind of a utopian version of the future, how we can share this information. We got some stuff coming from IETF, the SCIT working group. The CycloneDX team is also working on a more point-to-point. It's a simpler approach to how we share it at a more of a protocol level. So there's progress being made to make sharing easier because we all know it's a problem. But I think until we get this technical challenge solved and some of the contractual languages solved as well, mass sharing is just it's not going to happen, at least easily.
Well, and I would say until this podcast, prepping for this, I've been most interested in the business model around this from an OT standpoint, um, on the asset owner side, the people that run these ICS, the companies, and it's unclear to me that there is even a desire or it makes any sense for them to collect, most of the asset owners to collect all these SBOMs and be looking at them on a constant basis. You talked about having 10,000 customers. Well, a lot of these asset owners have a lot of products, so that what they're going to get all these SBOMs in and be tracking them on a regular basis. So I
Yeah.
think the case for the vendors makes great sense. It actually is going to improve their development process, improve their product quality. Even if they don't share anything, it's going to be much better. But the whole issue of whether the vendors will tell you when there's an issue in the product somewhere in the supply chain, or there's going to be some third party resource that everyone can query, and whether that's going to be an OT specific resource, I think that's fascinating. I think it's way too early to know how that'll play out, but that's something I'm watching closely. Uh, but do you agree
One
that
of the
it's very early, or what? Or do you have any predictions on how that's going to play out?
It is early. I think we're, we're certainly in the infancy, even though, bills of materials have been around for years. I think one of the challenges has actually been, quite honestly, the framing of SBOM, period. Um, software hasn't lived in a bubble in decades, right?
Mhm.
Software runs on something. It runs on hardware. It uses firmware. It calls out to remote services. We should be talking about bills of materials, not software bills of materials. So I think, in order to bring everyone to the table, maybe the term SBOM was probably the right thing to do. But nowadays, I mean, if you want to ignore the embedded device space, then, certainly SBOM would be a way to go. But we don't believe that that's the future, right? Everything that OWASP does, all of our projects, all of our conferences, they're really about three different personas: the builders, the breakers, and the defenders. And on the OT side, they are very much the defenders in a lot of cases, right? And we bring a lot of these capabilities to CycloneDX because the defenders have an equal seat at the table. So I'll give you an example. Um, maybe you have a bill of material for a device, and that device relies on, maybe it relies on another device, or it relies on some other kind of service, whether it's an internet connected service, whether it's a satellite com type of thing, whatever the case is. You can actually describe the entire product, and as well as the entire dependency graph, including those services, in your bill of material, so much so that you have enough information to automatically generate a threat model that will actually help you start identifying where your different attack surface vectors actually might be, right? So as a defender, we try to give you as many tools as possible in the bill of material format to be able to represent this. We even give you like things like data and data classifications and the directional flow of data, because having a device, especially a connected one, all that data just doesn't live on a device, right? It talks to other things in the environment in which it's deployed. And right now, unfortunately, most BOM formats are not discussing these. We're really the only ones that have supported this more holistic view of bills of materials since inception. Um, so I think the framing of SBOM has, while it got everybody to the table, I think it's also limiting us now, as many organizations are wanting to start adopting some of these other use cases, and they're not necessarily finding the utility in the SBOM framing to do so.
Okay. Boy, I could ask a lot of questions on that, but I want to dig into the details. Let me just ask you one more market question, and I've written my thoughts on that, so I'll keep this to an interview. How much increase in, let's say, what you're seeing in terms of your statistics of use, or just your own view, has the presidential directive and other government regulations here in the U.S. and also in Europe? We're seeing this now as well. Saying there's I forget what it's called. It's like the CRL or CRA or something like that. That's saying you need an SBOM. How much has that increased the interest and usage in SBOMs?
So it's interesting because dependency track has existed for 10 years already. In fact, we're actually celebrating our 10th year anniversary. The NTIA SBOM effort kicked off in 2018, so several years, 5 years after dependency track existed. Since that time, we have seen dramatic spikes in usage. We might have had, quite honestly, we might have had 50 people using it before the executive order. I'm sorry, before the NTIA efforts. Once the NTIA efforts actually started, and they started talking about SBOMs a lot more, the adoption rose significantly. Then the executive order hit, And we can measure this based on Cloudflare traffic to our website. We can measure it based on downloads and download dates. But once that executive order hit, that really spiked dependency track usage and thus CycloneDX adoption as well. Right now, it's an open source project, so we don't track all the usages. We have a different way that we track it, mostly through Sonatype, because they have a service called OSS Index that is freely available, which dependency track uses. So we know, for example, that 400 million components are represented in CycloneDX every single month and are analyzed for known vulnerabilities. But prior to that, it was 100,000. Then it was 300,000. And now it's 400,000. And the trajectory is really interesting to watch. The other thing that I think other organizations are, now that the NTIA and now CISA work is done and the executive order is a thing, we're also seeing like standards like SCVS and some other standards. Well, even SSDF, which from NIST refers to OWASP SCVS in its entirety, which requires SBOMs. And so you're seeing a lot of these maturity type models for development come about and being an SBOM kind of being a requirement of those. So I think we're not only seeing the adoption from selling to the US federal government and that sort of thing, but we're also seeing increased adoption just from SBOM being a best practice, right? You can't defend what you don't know.
Well, you can, but it's harder.
Exactly.
You can better protect if you know what you're protecting, is what I like to say.
Yes.
Okay, and just one last question on that. Are you able to break it down by Europe? Are you able to see what's coming in from Europe? Because they're facing some pretty stringent regulations in a few years. So they kind of had their presidential directive moment recently. Are you seeing any uptick there?
Yeah, we're not tracking dependency track usage that way, but we do track CycloneDX website metrics that way. The majority of our traffic, millions of hits a month, come from the US. Okay. But the second largest country is Germany, and by a fairly large margin. So we're seeing Germany. I think France is next. So we are seeing a lot of European traffic. If I had to add up all the European traffic, it would probably be around, my guess, these are not hard numbers, my guess would be the sum of all European traffic would probably be around 70 to 80% that of the US.
Okay, well, that's a lot. Now let's get into some of the details. So your organization, I'm sure you had a large part in it, recently published in June of 2023, the Authoritative Guide to SBOM, which was the first detailed SBOM document I read. I've just kind of kept at a high level business case thing, but this was very interesting. I thought it was well done. I would recommend it. We'll include it in the show notes. But it raised some questions as I started to dig in. So why don't we start? You mentioned NTIA, that government agency that kind of kicked it off, and now a lot of that responsibility has moved to CISA. But NTIA had minimum elements for SBOM, which when they say minimum elements, they were pretty small. They were very minimum, especially compared to the elements, the components and all the various other categories you have in CycloneDX. What's your view? Is that an acceptable list of minimum elements in your standpoint, or does the 3 or 4 years since it came out warrant a relook at that?
I don't think it was. I would have gone much further in if I was writing the minimum elements. I would have gone much further. In fact, the CycloneDX team, prior to joining OWASP, mind you, we actually did provide our feedback because NTIA did request public feedback. Some of the feedback, I can't recall it verbatim, but I believe we included hashes because in a lot of cases, not all, but in a lot of cases, hashes are very important. The other thing I think we included was licensing, because license, although it's good for compliance and intellectual property use cases, absolutely has a security implication, right? If I'm using an AGPL license and I modify that particular piece of software, well, now I have to actually disclose my intellectual property, right? Now it becomes a security use case. There's all other security use cases revolving commercial software, right? What happens if I'm using a commercial component? That thing is licensed, and now the license expires. Now I have, in terms of confidentiality, availability, or integrity and availability, now I have an availability problem, or worse yet, the application now performs differently than what it did before. So certainly a security problem, possibly a quality problem. I would certainly add both of those today. I think both of those are incredibly valuable for most organizations. One thing that I would actually remove from the NTIA minimum elements is the supplier. And I'm not talking about the supplier of the product that you actually purchase. I'm talking about the supplier for like the open source components that you're using in your application. The reality is that most suppliers are in fact individuals, like millions and millions of individual people who just happen to have a library available, and that library just happened to be used by a medical device or some kind of national defense type of system. It's not that supplier's responsibility. I would actually remove that because one, it's incredibly hard to automate the creation of that because most packaging ecosystems don't actually support that. If you go to PyPy in the Python ecosystem, if you go to several other ecosystems, the concept of a namespace or a group or that it really doesn't exist. So you'd have to change existing packaging ecosystems for this to be automatable. The NTIA minimum elements really stressed the focus on automation, and yet they included an element which is really difficult in most cases, not all, but in most cases, to actually automate. So I would actually remove that. But there's a lot more that I would actually add in its place.
But just so I understand it, when you're talking about the supplier, so if I'm buying a PLC from Schneider Electric, they would be the supplier of that device, and then that device might have software from a variety of places. And you're saying you wouldn't have the supplier of, let's say, a library or something that was in that device. So how would you know would you know who to track down to see if there was an issue with it? If you didn't have
what I would have done instead was identify different types of data that you'll be able to correlate who the supplier is. So instead of directly having the supplier, which again, it's really hard to automate in most cases, I would have added additional fields that we could triangulate who the supplier is.
Okay. Let's shift to components, because my view of SBOMs, and I think a lot of my listeners' views of SBOMs, probably the primary part of your BOM and CycloneDX would be the components and the various elements in the component field. One of the things that was interesting was this trying to measure the completeness and confidence in that list of components. And first of all, I would say that even if it's not 100% complete, 90% complete SBOM still has value. I think that's one of the things I've had a few people in this industry, really technical people, evaluate some of the tools and find something missing from the SBOM that created the tools, or from the company that created the tools, usually from binaries, people trying to figure out what's the SBOM for this legacy thing. And they said, see, this doesn't find everything. It's not that good, but you can get a lot of value out of a 90% accurate SBOM. So I think it's not 100% or nothing. But you had various fields here. For example, you had a completeness field, and you talked about having complete inventory of first party and third party components. And I guess, how does someone looking at this know if it's complete? Is that just the person that created it, their view of the completeness, or is there some other measure that gets that field filled?
Yeah, this was some work that NTIA did in the early on in the framing working group. They had this concept called known unknowns.
Hmm.
Basically, if you have, you mentioned the PLC from Snyder Electric. If I'll take that as an example. So I've got this PLC. I'm using this component from this other supplier, but I don't actually know what's in that component because that supplier is no longer in business and I'm never going to get an SBOM from them.
Hmm.
So I'm using this component. I have no idea what's in there. I can actually describe the fact that I think all this other stuff is complete, but I know that I have no idea what's in this other thing. Certainly valid use case. And I completely agree with you, right? A partially complete SBOM is better than no SBOM at all. I am certainly not on the fence of on the side of being, you know, um, accurate or go home, right? That's not where we should be as an industry.
Hmm.
We should be, promoting the fact that SBOMs, we're going to get them wrong, and that SBOMs are a process, and we're going to learn together as we go through this process and journey together. And in the process, we will eventually start coming up with new ways to identify whether or not this SBOM is complete or not. Right now, I don't think we're there. Right? We have a chicken and egg issue, however, in that we first needed a specification to be able to represent this type of data. And because we have this type of data now we're going to have some tools, and there are some tools that are actually coming along to actually start measuring completeness. So that's actually a great thing. Some of the stuff that CycloneDX has done has actually led to the creation of brand new open source projects, and in some cases, brand new companies that never existed before that are actually taking advantage of certain capabilities in CycloneDX. But there's a lot of capabilities in Cyclone that isn't just about like SBOM, right? They're for whatever reason, talk to lawyers. I'm not a lawyer, but for some reason, some companies want to only provide the third party components that they are distributing. Some companies want to only provide an SBOM with the open source components that they're using. So you need to be able to provide a way for organizations to describe what exactly they're trying to communicate in that bills of material. And that's really what the compositions is all about. You alluded to the confidence and whatnot as well.
Yeah, I
So,
was going to ask you about that because that one seemed very arbitrary. That was in the evidence section, I think. The
yeah,
confidence.
yeah, yeah. And this gets really arbitrary. Again, I think you mentioned binary, looking at binaries, it gets really arbitrary for binaries for sure. But there's a lot of different ways that you can certainly create an SBOM, right? You can look at package manifest. You can do different types of AST, abstract syntax tree type of analysis. You can do hash comparisons. You can do different types of binary analysis. You can do a lot of different ways to different techniques to identify what a component is. And depending on those techniques, some might be better than others. And if you combine multiple techniques, well, you might actually increase your overall confidence in your assertion of that this component is in fact OpenSSL version X. So I think it was really important for us to provide that evidence because again, this is on a per component basis. And I might have 100% confidence in being able to identify, log4j versus maybe only 70% confidence in multiple techniques to be able to describe maybe some embedded version of OpenSSL on some device that I got. So it was really important for us to be able to provide a specification, a place where you can actually put this data. Because again, now that we have this data available, we're actually seeing the emergence of some tools that actually make use of different techniques and they're now actually supporting the evidence part of CycloneDX, which is great. So on the consumption side, when you get a bill of materials from a supplier or whomever, you can now look at the evidence to see the methods, the techniques, the confidence that the vendors actually gave to those things, because that will actually tell you really their level of maturity in actually creating the SBOM to begin with.
Another area that I hear, Steve, that is causing problems, and I hear this from the OT detection vendors and the OT asset inventory vendors, because there are some that are just doing focused on asset inventory, is when they start to look at the vulnerability management side of that, they complain about a naming issue, that they say that there's so much difficulty between the CPE and the NVD and all this, that they might have various vulnerabilities identified by different names, and there's not like a one-to-one relationship. Some component might be called 3 different things in 3 different databases. I guess the question would be, is that a problem you see, and how does CycloneDX deal with that today? Or if it's a problem for you, what's the solution for the future?
That is complicated. The naming problem isn't just about the components themselves, right? Is it called OpenSSL, or is it called OpenSSL project? The naming problem isn't just about that. It's also with CPEs. It's also with CVE identifiers as well.
Yep.
That's a completely different issue. There is certainly a challenge. There's certainly a legacy data issue with the NVD. Now, AppSec folks, application security folks, we haven't used the NVD in well over a decade. It's not useful for us at all. We primarily use SCA vendors, and most SCA vendors, they also don't use the NVD. They've actually, in most cases, built up their own database that doesn't have all of the erroneous data issues, and they certainly don't use CPEs. So CPE is certainly a challenge, and all the legacy debt in terms of the data in the NVD is also a challenge. CPE is interesting because most CPEs are not actually reported until there's a vulnerability discovered. And so you can't proactively monitor something unless it's previously had a vulnerability, which from a vulnerability management perspective is kind of nuts, right? That's not an ideal situation. What you would want to have.
Yeah, it's a big problem in OT. Sorry to interrupt, but in OT, where we're just getting dragged into, well, we have been for a couple of decades, but there are still many vendors that supply OT products, especially at level 1 and level 0 in the Purdue model, that have never dealt with a vulnerability disclosure before. Even though their product is rife with it, it just hasn't been looked at by I guess what you would call the breakers. They haven't looked at this. So yeah, that's a huge issue in our space.
It is. And, within AppSec, we've been fortunate because we've had SCA vendors, but the rest of the world hasn't had that luxury. They're having to deal with the NVD and all the baggage that really goes with it. Not to really frown upon the excellent work that the folks at the NVD actually are doing. They're confined by their own financial situation, which Congress and everything else. So nothing against the folks working at the NVD, but they do have a lot of, the NVD does have a lot of challenges. The SBOM forum actually has talked about this at great lengths. It's interesting that CPE, it's not native to hardware, and it's certainly not native to software. It is really only native to the NVD, which is why it's always going to be wrong. We should not be using that. The hardware industry uses GS1 standards. That's what they use, right? There's global, GS1 is a international standards body. They have a GMN, which is for model numbers. They've got GTIN, which is essentially your UPC labels. They have all this already in the hardware space. There's no reason for the hardware world to use CPEs. For software packages, the majority of them are going to be open source. we have something called package URL. You don't need a centralized authority to do package URL, which is great. I have multiple sources of vulnerability intelligence today that support package URL, none of which are the NVD. The issue is the commercial vendors. So the commercial software vendors, how do you get them to do something that isn't CPE and do a better job? Well, there's this standard called SWID that I personally like a lot. It was, I think, given an unfair thing when it originally was part of the NTIA SBOM thing. SWID couldn't be further from being an SBOM format. It's designed to identify commercial software. That's really what it was designed to do. Can it be misused for SBOMs? Certainly, anything can. But it was designed to identify software. It's literally in its name. And that can also now be represented in package URL. You can represent the identity of a software using package URL. So we actually put forth a document, the SBOM forum did, recommending that the NVD start deprecating CPE. You can't get rid of it entirely because entire industry is kind of built upon it. But going forward, you can certainly add GS1 standards, GMN, G10, for example. You can certainly add package URL and then start phasing out CPE over the next 5-10 years. But that would allow you some really powerful use cases, right? Imagine being able to go to the on the back of a router, entering the UPC code on the back and getting a list of vulnerabilities that affect that Cisco router, or going to a central place on whether it's the NVD or somewhere else, a central authority that has a list of all the different commercial software vendors, all the different products, and being able to get vulnerability information for any given version of any given product, regardless of whether or not it's ever had a vulnerability or not. This is the state that we want to get to. And that document that the SBOM forum put forth earlier this year kind of lays a path, lays an argument for that type of future. What we really need to be able to support this is CVE.org. So all that MITRE work, CVE.org to be able to support this, which they're actually in the process of doing. And eventually, because the NVD is a downstream consumer of CVE.org, we need the NVD to ultimately support this as well.
Okay, thank you for that. That was a lot. I'm going to have to do some research on some of those acronyms you put out there, but I'm sure a lot of our listeners are going to find that very interesting. I want to stick with vulnerabilities for a second. As I understood the model, you would have an SBOM that would feed dependency track, and then dependency track, one of the things it would do would be to tell you what vulnerabilities occurred. But then the SBOMs themselves, and this is something I think a lot of our listeners are familiar with, the community came up with VEX, which would be a way for the supplier, the builder, to say, yes, there's a component with this vulnerability, but that vulnerability can be exploited, cannot be exploited, or such. So essentially it would allow you to say, these are the ones that I don't have to worry about, even though I have a component, or let's say worry about less, and then these are the ones I need to prioritize. I think most people like that concept, that you should be able to focus on the most important vulnerabilities. But I heard you on the Future Application Security podcast. You said something really interesting. You said VEX itself is a missed opportunity because it doesn't represent risk. Can you elaborate a little bit more on what you meant by that?
Certainly. I think a lot of focus in the VEX community was really about the VEX format, what the quote unquote specification would be. Because I'm in the OWASP Foundation, and again, we really look at the builders, breakers, and defenders, I'm looking at VEX from a defender perspective. As a defender, the only thing VEX really provides me is it turns off some lights, right? It really requires me to analyze an SBOM, which is going to turn on a bunch of lights. And then Vex is going to potentially turn off a bunch of lights, which is great. I have less noise, but I still have more noise than what I had before because I've got a million other vulnerabilities in my environment. It doesn't actually tell me what things I should be worried about, though. And I'll give you a couple examples. I might have maybe an access control system for the building, right? A card reader or whatever the case is. And maybe it's exploitable to log4shell, right? 10.0 CVE. I've got 100 of these devices in my environment, and every single one is exploitable. That exploitability, however, doesn't take into consideration a lot of the context in which that exploitability actually occurs. For example, if it's only exploitable by administrators who already have that privilege to execute code on that device, does that 10.0 CVE introduce any risk than what I already have today? No, in fact, it doesn't. Is it a vulnerability? Yes. Does it introduce additional risk? No, it doesn't. So if I've got 100 of these things in my environment, and I've got this one other thing that maybe it's a medium severity or 7.0 CVE, CVSS score, and I concentrate on fixing the 100 things that don't matter instead of the one thing that actually does. So that's kind of one of my concerns that I have with Vex, right? Everybody is under, especially in the security industry, we are all under time constraints. We all have a mountain of signals that we're trying to pay attention to. And I think Vex was a missed opportunity because it doesn't actually communicate the risk of that vulnerability in the context of the application.
I guess you could put more information in terms of the context of the application, but a lot of this, and this was something Art Mannion started back when he was at CERT. He gave a presentation at S4. He called this new method the SSVC, but really it was a decision tree model. And I've put one out for ICS, but it's much more of a asset owner risk decision. A lot of the most important elements that would determine whether, if I'm advising an asset owner whether they should patch it or not, the vendor would not know. The vendor could not include in Vex or SuperVex or whatever format you wanted. I mean, it doesn't know, for example, if I'm using it in a safety critical operation. It doesn't know if it's accessible from a network outside. It doesn't know, it doesn't know. There were like 5 or 6 categories that went through a decision tree. So I could see how you could include more information on it. To me, that what you pointed out is more of a problem with the CVSS score, is like a CVSS score for something that says it requires administrator access to do it. That shouldn't be a 10. I mean, because like you said, that's something that you already know. So I would, in my view, it'd be better to improve that metric, because that's something the vendor can know. But so much of the risk is only going to be known by the end user, the defender, in your words.
Yeah, that's I've kind of gone back and forth with CVSS in my own kind of thinking. But again, CVSS is really about severity. It's also not about risk.
Yep.
I think the other missed opportunity with Vex is that they were looking at vulnerabilities in isolation.
Mm-hmm.
And the real world doesn't work that way, right? The adversaries don't work that way. Defenders don't work that way. But it's describing one vulnerability and the impact or exploitability of that one vulnerability in isolation.
Mm-hmm.
The reality is that these things can be piggybacked, they can be chained, and chained together two low severity issues could actually result in a high impact issue.
Okay, I've kept you for almost an hour. I want to hit 2 things really quickly. Okay, I appreciate the time. And I think these are going to be, one is going to be very new to the audience. You talk about software factories and other ways that these builders can generate SBOMs or can generate bombs in CycloneDX format. And I guess without getting, we don't have a lot of developers on this call, but my understanding is there's plugins for a lot of these build tools that one of the things they will do is not only build the product, but also put out a Cyclone DX bomb. Is that what I was reading there? Is that correct?
Yeah, there's lots and lots of build plugins that we support. I think we have pretty much support for virtually every language at this point. I'm sure there's some obscure niche languages that we don't support, but by and large, every major language and even the non-major languages are fully supported. And those are just build systems, right? So the interesting thing about build systems is that you're usually, not all the time, but you're usually going to get the most accurate results if you integrate it into your build life cycle. And the word life cycle is key here because builds actually go through a series of steps throughout the course of its life cycle. And depending on that particular step, it might actually resolve other dependencies or different versions of prior dependencies. So it's really important to capture that entire life cycle if you want a more accurate bill of material. But that approach, while generally more accurate, is a little bit more time consuming. If I've got 1,000 different builds in my environment, I don't necessarily want to visit 1,000 different builds to be able to add these plugins. Sometimes I might want the easy button. And software factories are the things that usually orchestrate all these builds. And GitHub Actions is a software factory. Jenkins is a software factory. There's a lot of different software factories, CI/CD systems that exist that you can integrate the generations of bill of materials at this level. You typically don't get the accuracy that you would if you integrated it into every single build manually. However, if you want to be able to get a lot of SBOMs really, really quickly across your entire organization, that would certainly be the way to do it in your development pipeline.
And I would encourage people to look at that authoritative guide to SBOM because that has some really good sections about you have the blocks with the different parts of the process of generating and supporting products and where they fit in, and it's really well done. I learned a lot from that. I mean, there's so many other things I could talk about: BOM identity, integrity verification, XBOM versus SBOM. But my last question or area I wanted to talk about was this outdated component analysis, because that was a little bit in the document, but it wasn't really described a lot. And we have a lot of outdated components in OT. I mean, these things last for decades, and the companies may have been gone for 10 years and they're still sitting in there. So what kind of capabilities or documentation of outdated components are in this CycloneDX?
Yeah, so that's using primarily using package URL today. You can identify whether or not a package, a software package, is the current version. You can identify maybe if it's one or two major versions behind, or maybe if it's like 5, 6, 7 years old. So you can perform all this type of analysis today. What is a little bit more challenging are the non-packages, right? The things that were compiled maybe from C that there are no packages for, right? Because there is no package repository for those components, as well as all the commercial software. And there is a project from the OASIS group that is formalizing a end of life, end of support schema that will allow us to start representing a lot of this product life cycle type information, the dates of when stuff was produced, when it was distributed, when it was end of life, when it was end of support, all that kind of great information. We will now, in the very near future, have a specification to now represent that kind of data. Now that we'll have a specification, which is great, now we just need to start populating that, right? Where do we get this information from, especially from commercial vendors? Sometimes products go through really odd life cycles, right? Sometimes a commercial vendor will say, well, we're not going to support this thing, and it won't be supported for 2 years. And then they'll have a customer that says, well, I want to give you $1 million, and okay, we'll support this thing now. Yeah. So you have these kind of situations like that. And that's not just for commercial software, by the way. This actually happens in open source as well. There was a open source UI project called Bootstrap. Originally, it was from Twitter, but it's the Twitter Bootstrap project, and the stable version at the time was version 3 dot something. The alpha version at the time was 4. They literally end of lifed 3.0. They deprecated 3.0. So the only stable version was gone, essentially, end of support. So they could actually focus on getting version 4 actually to a stable place. Once 4 was at a stable place, they brought 3 support for 3 back. So these things go through different life cycles like that. So being able to capture that in this future OASIS standard, I think is going to be great. We'll just need some kind of central repository and mechanism in order to share this information.
Great. Well, Steve, I'm going to stop there because I could just keep talking to you and asking you more questions. So I might have to, as I get smarter on this, I might have to do a part 2 with you. But my guest this episode has been Steve Springett. He is the Director of Product Security at ServiceNow, Chair of the OWASP CycloneDX Core Working Group. If you want more on CycloneDX, you can go to CycloneDX.org. And Steve, if someone wants to follow you or reach out to you, are you active in any of the socials?
I am, yeah. I am on Mastodon. I'm on LinkedIn, and rarely, occasionally on Twitter X, whatever it's called now. So you can find me on there, Steve Springett on all 3. And if you want to participate in CycloneDX, go to cyclonedx.org/participate. There'll be links there to the mailing list. I'm very active in the Slack workspace over there as well.